So quickly going through the answers to the four polymerization questions. So the first one hopefully is a fairly straightforward adaptation of what we had in the core notes. And you'll see first of all that the difference is that with the diamine it's a benzene ring between the two NH2 groups. So we draw out the benzene dicarboxylic acid. Again, my drawing package had a calculate type structure, but you could equally put the delocalized pi ring in the center there. Then we've got the diamine, this time with the benzene ring between the two NH2s. We put N in front of it if it's going to be an equation, and then that'll turn into, and there's a repeating unit, so the OH comes off the acid, so we put our bracket here, the H comes off the amine, so we put our bracket there, and then that's repeated N times. And then again we get 2N water, and being strict 2N minus 1. The diaminobenzene and butadioic acid, so diaminobenzene would be that, so benzene with two amine groups, butane dioic acid, 4 carbons with 2 acid groups at either end, N of those. And then when we draw the repeating unit, we take off the hydrogen of the amine, benzene ring, the hydrogen of the amine group against the NH, C double bond O with the OH removed, 2 carbons, then C double bond O with the OH removed. And again, that's repeated. Apologies. That's repeated N times, and we get 2N minus 1 water. The third one, now this is a slightly unusual molecule, and if you look at this molecule, you'll see COH at this end, slightly skeletal representation of it, and an OH at this end. Now, to show this, I'll line up the molecules. We'll do the equation in a moment, but line up the molecules. And this time we've got 2 different groups on the same molecule, but we can still get a polymerization. So if you line up the molecules like that, you can still link those together to form the polymer. And so what will happen is, again, you'll get water eliminated, and you'll get a repeating unit, something like that. So to do it in terms of the equation, now this time you just need to start with a large number of these. You don't have two monomers this time, you've just got the one type, so a large number of these molecules, and they will turn into, and basically what you've done is you've taken an H off one end of the molecule and OH off the other. So there's the OH off the acid group there, there's the H off the alcohol group, and that's repeated N times. And to balance it up in terms of the water, this time you'd get N waters, because you've got N of those molecules, and again, to be absolutely strict, minus 1 to take account of the end of the polymer chain. And finally, this one, where you were given the repeating unit of the polymer. Now, the first thing to do with something like this is identify what it is. This is a polyamide, we can tell it from that. That means that we split the molecule down the middle there, or the repeating unit down the middle there. And that means that we would have the dioic acid, or equally, instead of having OH, you could have chlorine here. That would be an effective monomer as well. So that would be the dioic acid, and then you would have the diamine.